In the last lesson I said that if the radicand is not a perfect square, you can't simplify the root. That's not entirely true. You can simplify it, you just can't write it as a rational number. What ends up happening is you simplify it and it's still an irrational number, but it's a very important simplification, as we're going to see once we get to adding and subtracting radicals. So for a number like root 12, you can factor radicals in exactly the same way that you can factor integers. So we could write this, for instance, as root 6 times root 2. The problem here is that this doesn't really do us any good because we can't simplify root 6, and as we've seen, we can't simplify root 2. Now if you notice on the right, I've got the first few perfect squares, and the implications of that, the square roots of those perfect squares, which are integers. They're capable of being simplified. So this doesn't do us any good, root 6 times root 2. But there's another way to factor 12. You can factor 12 as root 4 times root 3, because 4 times 3 is 12. This all of a sudden is now quite useful, because we know how to simplify root 4. Root 4 is just 2. And so all we do is we replace the root 4 with 2. The root 3 still stays there. And so this is just simply 2 times root 3, which is commonly read as 2 root 3. So we have simplified root 12. We just haven't written it as a rational number. It's just a multiple now of a smaller radicand, a smaller irrational number. So let's do the same thing for root 20. Again, not all ways of factoring are going to be helpful. For instance, you can factor 20 as 2 times 10. It doesn't do us any good. So if you look at the list on the right, what you're really looking for are perfect square factors of the radicand. 20 has a perfect square factor, which is 4. So we can write this as root 4 times root 5. And again, we can replace the root 4 with just simply 2. So this becomes 2 root 5. Let's try it again for 50. All right, go down the list on the right, if you like, and look for factors of 50 that are on that list. 4 is not a factor, 9 is not a factor, 16 is not a factor, but 25 is. So we can write this as root 25 times root 2. Root 25 is just 5, so this becomes 5 root 2. How about root 72? Okay, let's go down the list here. 4 is a factor of 72. So is 9. So is 36. Now, if you spot that 36 is a factor of 72, you can go right away to writing this as root 36 times root 2, and this becomes simply 6 root 2. What if, though, you don't spot that, and instead you get stuck on the idea of, for instance, 72 is being factored as 9 times 8. So you write it as root 9 times root 8. Root 9 is an integer, it's just 3. So you have 3 root 8. So what's correct here, 6 root 2 or 3 root 8? They're both correct. The problem is that 3 root 8 is not fully simplified because you didn't pull out the largest perfect square factor. Root 8 itself can be further simplified. Look at the list on the right. You'll notice that root 8 does have a perfect square factor, which is root 4. And so you can replace the root 4 with simply 2. So we have 3 times 2 times root 2, which gives you 6 root 2. And that is exactly what you had here. So if you want to save yourself some time, look for the largest perfect square factor and pull that out first. So let's try that with root 300. Root 300 obviously has some perfect square factors, like 25, for instance. But is that the largest perfect square factor? No. If you go all the way down to the bottom of the list, you see 100 there, and that's clearly a factor of 300. So the best thing to do is to take out that root 100, and then you're left with a root 3, and then you're left with 10 root 3.